I've been looking forward to this. So I'd like to welcome Kat. Kat is a developer advocate with Open Robotics. As I just discovered, she is their only developer advocate and is very busy. But she also knows a lot about what's going on with the ROS. Customers, internally, and with that, Kat, maybe you could give us some background, tell us how you ended up here, and then get to your slides.
Cool. Hi. Well, I'm Kat. Yeah, I'm the lone developer advocate. Some reason people think Open Robotics is this giant organization, and it's really just shy of 50 people spread out over like 3 or 4 continents. And so I don't know, maybe it's because the outsized influence ROS has on stuff. But they think we're a big organization, and I am the fairly new single developer advocate, which really means I do a lot of things that aren't writing code, which I'm one of maybe 2 people that do that at Open Robotics. So yeah, I was going to go walk through. I hope I sort of set the right level here. So I'm just going to kind of walk through and explain what ROS is and how it came about and sort of the ethos of how things get done, and explain ROS 2 to people. Hopefully that's the right level. Since this isn't like a ton of people, feel free to just kind of slap questions in there, and I'll try to take a break every few minutes and answer them. If I start rambling, tell me to keep moving on. This isn't interesting, because it's always about sort of finding what the audience is familiar with and not familiar with. Let me see if I can present. Present my entire screen. That's usually the easiest. All right, you guys ready to go into the crazy mode for a second? And see that? I look good?
Yes. Yep. Looks good.
Whoop. Gotta go to the beginning. There we go. All right. So, no, please don't do that. All right. I got a teaser there. So I'm just going to talk about ROS 2 generally today. I'm the developer advocate at Open Robotics. You can get me at this. Also, my address is just kat@openrobotics.org. Feel free to shoot me questions. I try to answer things. We do have a Q&A forum, so sometimes it's not best to ask me technical questions, but more like, who do I talk to if I want to learn how to do this? I can direct you in the right direction or point you to the right resources. I also want to point out a couple things just that happened in the past 7 days. I'm not going to drop them in the end of the presentation, but yesterday, most of the day was the third DARPA Sub-T challenge. So the DARPA Sub-T challenge is this big event put on by DARPA. We're a contractor for it, but what they do is if you're familiar with say the Urban Challenge or the Grand Challenge, they basically every couple of years put together some hard task that they want robots to do that robots can't do yet, and they get a bunch of people to try and do that task, and there's some set of winners that come out of it and they win a prize. So this iteration of that fundamental idea is about getting robots to go around in enclosed spaces without GPS and to explore them and find stuff. And the environment they're kind of looking at are caves and underground tunnels and mines and stuff like that. So they just wrapped up the third installment of that program yesterday. There's a bunch of cool videos. Unfortunately, due to COVID, they did it all virtually, but it ended up working out. We can now do really, really high fidelity simulations of some of these terrains and some of these robots. And they were able to sort of move these simulated robots through 4 mile long simulated caves with landslide or rock slides and smoke and haze and water hazards and stuff like that. So it's worth checking out. There's a couple links right there. Also, last Thursday was ROS World. So ROS World was our we're not going to have our regular yearly conference. We're going to try to do a small virtual conference. And when I say small, it was supposed to be a few hundred people and it ended up being a few thousand people. So if you want to sort of get an idea of what ROS is capable of or see what people are working on, I just click the button to put all of the talk videos up on our Vimeo site. So that's worth checking out too. All right, so when we get in the talk, I'll explain what ROS is, so then you'll understand why you want to go take a look at these things. And generally the way I do this is I start with social proof because it makes people pay attention. And it's also this situation where ROS is fairly old, so I'll talk about the history of it. ROS is 13 years old, and people kind of sometimes remember it from a few years ago and have this one mindset about it and haven't really changed that mindset about how ROS has changed. And I kind of address that by giving people social proof. I talk a little bit about the philosophy, about how things are built in ROS and why they're built that way. What's in the box? What does ROS do? How do you do things with it? Or at a high level, what is it capable of? And then I talk a little bit about the community and sort of all of the resources that we manage that make it possible for people to build things with ROS. So why should I care about ROS 2? I keep saying this ROS thing. I should define it. ROS stands for Robot Operating System. ROS really isn't an operating system. It's more like a layer on top of like a Linux operating system or now other operating systems to make robots possible. And it's roughly the largest, oldest, fastest growing ecosystem for robotics, and it's free and open source. And this gets to the social proof. This isn't actually everyone. I need to update this slide. We actually added a new TSC member like 2 days ago. Wind River joined us. But this is the ROS2 TSC, and the TSC, or Technical Steering Community, sort of directs and donates engineering time to building ROS2. And so this gives you an idea of who's interested in ROS and who's working on it. And it's not just this tiny little product. There are big companies trying to build this sort of open source infrastructure to build robots. This slide is outdated. I actually have 2020 numbers posted up on ROS Discourse. But this gives you some metrics about ROS use. And it's worth noting that like this first number, 300 companies using ROS, at least I know some of them are Fortune 50s, some of them are small startups, there's everything in between. This is my own number, just recording every time I have somebody email me with a question or something. We have a BSD license, so we don't know who's all using ROS. So this number could be 2 orders of magnitude bigger. We don't know, and we'll probably never know. We had 264 million dev downloads in 2019. We're going to way shoot this number, overshoot this number this year. The other thing is that sort of concurrently, people aren't using devs as much anymore. They're using Docker containers, and those numbers are crazy high as well. We have a Q&A forum with 35,000 users. We have a discussion forum that's got about 5,000 users. If you search GitHub for ROS, there's easily 2,000 ROS repos. Our wiki gets 200,000 visits a month. I think this year this is actually over 8,000 or pretty close to 8,000 research citations of the original ROS paper. We also have a metrics website, metrics.ros.org. And I say all this stuff just to give people an idea of how big the project is, but also give people a resource of like, I'm having a discussion about using this at work. People sometimes need social proof to understand that this isn't just a tiny fly-by-night open source project. And so having some of these numbers really helps. And then also, yeah, I said all this runs on Linux. Well, it also started to run on Windows, which I think is really big for sort of legacy and big manufacturing operations. So that's a changing, something that's evolving now that wasn't possible just a few years ago. Let's see. I can't see both screens at the same time. Cool. All right. No questions. I'll keep going. So let's talk a little bit about ROS history. In the before times, before ROS, building robots was this capital intensive, repetitive, highly manufacturing driven sort of thing. And they were only doing dull, dirty, and dangerous jobs. And so you're only really using robots in the 80s and 90s if, you were doing a very capital intensive, very repetitive task. And that was just the nature of robots that they were built for. That's what people did research about. There may have been research, for the far future, but that was not something that was out there in the world. By that, by extension, what did the software look like in the sort of before times? It was all proprietary stuff that works on Windows 95, bespoke by a vendor who had their own hardware controller, who gave it to a system integrator to do something. And it was really, you sort of paid somebody to come in and build the robotic system that you needed to do the one particular dirty, dull, or dangerous task. Really also these things were very feed forward, so it wasn't really like, oh, I have a bunch of cameras controlling stuff. It was really just do the same thing over and over again and try not to hit anybody. About when I left undergrad, things about 2004, things started changing, and it actually started changing, and I think that's why these DARPA events are interesting. It started changing because of these sort of events that were happening. And so this is for the first Grand Challenge, which was in 2004. DARPA said, hey, let's go take a bunch of universities and other organizations and have them compete to build a self-driving car out in the desert where they're not going to hit anybody. And what I think is interesting about that whole process, all those things that happened in 2004, 2005, 2006, is that it got people thinking about what robots could do and what the future was going to look like. And it moved things from, hey, a robot is something that goes in this very specific place to do a very specific job, to something that might be more flexible or need to be more flexible to do new things. Also, about 2004, other things are happening. Google has an IPO. There's a bunch of money floating around Silicon Valley, and it all goes into this pot where everyone's talking about, well, all of this Web 2.0 stuff is also built on free and open source software. There's all these flexible robots. There's all this IPO cash. It all goes into a pot. It all gets stirred around. And one day, poof, somebody says, hey, why don't I just kind of create this robot research facility? And can we do free and open source software for robots? And that organization was called Willow Garage. You can see one of the robots that they produced on the right. That's a PR2. And Willow was really this nexus of, like, in the history of Xerox PARC, let's have a place where people go and build interesting software, but also open source software. And from sort of Willow, 3 projects were born. You may have heard of some of them. One is called OpenCV, or at least a lot of the development of OpenCV happened there. One was called PCL, which is Point Cloud Library, and then the last one, which we'll talk about more here, is ROS. So these projects were kind of born, or at least expanded during this time at this organization. We also Willow also produced 2 robots, one called the Turtlebot, which I have an illustration on the left, and one called the PR2. And what happened is these robots got sort of sent out into the world. Hey, we're building the software, we're building these robots. Do you want one? Do you want to do some research? All we ask is that you sort of contribute your code back. And so this was really, if you think back, this is like 2007. This is when people were still using CVS. It wasn't like we had GitHub everywhere. This was a really early sort of, let's build open source tooling for robotics, and let's share what we're working on so we can accelerate our development and do better and more interesting research. And so for ROS, that whole ethos from that global research community is really baked into what's going on. And there were some, rough tenets, I think, that you can sort of summarize that really drive how things are done. And these are roughly how I characterize it. So the first one is federation over centralization. So we're not one big giant monorepo of software. It's really tons and tons of different packages that are interoperable and can be used together. Because of that, everything is built out of it's the same sort of Linux philosophy or Unix philosophy of small, simple, composable utilities that can be strung together to do something that's greater than the sum of the parts. Along those lines, since you're building lots of little utilities, don't reinvent the wheel, build shared common tools. This one I think gets forgotten about a little bit, but it's also built in a way that's non-exclusive. That is to say, there is support for multiple programming languages. There's some packaging infrastructure that allows anyone to sort of build their package and join the team. The project was also fairly inclusive. It was one of these things where, oh, well, this code and this code can be used in addition to this thing. We're not going to say you can only use ROS and not use something else. It's sort of an inclusive environment where you take what you need and leave what you don't need. And then finally, just this notion of freedom, where everything was under a non-restrictive license. So in 2013, Willow folded, but sort of the open source lived on. And basically 2 organizations came out of that. The one that I work for, Open Robotics, and then a second organization, ROS Industrial, who's sort of our sister organization that focuses on like particularly industry applications of ROS. And they're down in Surrey, or Southwest Research Institute. So about 2018, after a decade of work, we decided to start working. And after a decade of work, we're basically like, well, I think we've gone through enough iterations of ROS 1. We understand what we did well. We understand some of the things that weren't done well. It's time to start talking about a new version of ROS. So we start work on ROS 2. And part of that process was also putting together the TSC to help drive that process for building ROS sort of for this next generation of industrial ready robots. And so we've been working on it. We've been working on it since 2018. We're now at Foxy Fitzroy, which is the 6th ROS 2 release, and this is an LTS release, so this will be around for a few years, and we think it's reasonably well baked, and people should give it a shot. I think we pulled in, when we built ROS 2, we pull in the same sort of philosophy that came out of Willow, right? Which is don't reinvent the wheel, build a bunch of shared common tools, focus on federation over centralization, build small, simple, composable utilities, make it such that it's non-exclusive. This is to say, polygot builds and lots of packaging so people can, or lots of packaging tools so people can bring in their own bit of code. Make it inclusive, which means make it something that you can use in addition to something, not in place of something. And finally, make it free, make it under a non-restrictive license. All right, so why don't I stop there? That's kind of in the first section. Everything makes sense? People are still awake, haven't fallen asleep? Okay, cool. All right. All right, so let's keep going. Cool. So let's talk of, when I say don't reinvent the wheel, let's talk about what's in there and what the wheels are in ROS 2. And I like to say that I like the traditional definition of a robot. A robot has 3 parts. It has some sort of sensors that take in data in the world. It has some sort of actuators that do something in the world. And then it's got control or smarts. That is to say, it takes in all that data and decides what to do with those actuators. So that's the most basic robot will have these 3 parts. And they kind of end up looking like this. So let's talk about what these bubbles would mean. In ROS, there's this concept of a node. And a node is basically a unit of process encapsulation. So it's just a process or a thread, or it's actually a process, running on a computer, doing something. And that's all ROS nodes are. And ROS comes with this set of tooling to basically make nodes, that is to say, make small reusable programs that can be hooked up to a larger robotics infrastructure. And ROS includes all these tools to compile, install, start, stop, pause, query the status of, and do all the CLI munging for these nodes. Basically, within ROS, you can run an unlimited number of nodes, and you can bundle them up into a bunch of packages. And a package is just basically a collection of nodes and software tools. And the other thing that's worth noting about all this is that you can do this in like a polyglot way. So if you want to use C++, you can use C++. If you want to use Python, you can use Python. We got some people working on Rust. There's people doing a couple things in JavaScript here and there. So it really is just this way of, hey, I have this code I want to write. I need it encapsulated and deployed in a robotic system. And so imagine a world where you can write C++ and Python programs that all start concurrently, that have hardware interfaces, that have configurable parameters, and may have some weird, like on startup control flow configuration issues. Imagine doing this yourself. And like, what would that look like? For me, that would look like a bunch of shell scripts that do a bunch of gnarly things. So basically, ROS has something called a launch file that goes with these nodes that takes care of all of that. So if you wanted to build a node that has actuators attached to it, build a node that has sensors attached to it, and build a node that has some sort of control to interop between these two, ROS has got tools to help you build all of that. So I talked a little bit about building processes within ROS, but ROS also has some tools to connect everything up. And so what happens is a ROS node which may be connected to an actuator, a sensor, or some control, has what's called a topic. And a topic is what is the glue that joins all these nodes together. And basically all a topic is it's serialization, right? It's a pub sub bus. So if you're familiar with RabbitMQ or Protobufs, Google Protobufs, it's kind of like that. So it's just a pub sub mechanism where you can create standardized messages that are serialized across different languages and exchanged between each of your nodes. And there's a bunch of standardized messages that we use for a bunch of different things. So there's messages for images and joint positions and things like that somebody's already cooked up, so you can just reuse those versus rolling your own. And the other thing that's really, really cool about this is that, since it's a standard interface, since it's something that people keep doing over and over again, we've built up a lot of sort of software around it. There's a bunch of tooling associated with these topics. And these topics allow you to do stuff like, hey, I have this sensor, I want to go see what it's doing, so I can fork into like this sensor or this image topic and go put it on my screen. Or I can see like, what the rate is of the sensor's data coming off, or the rate of the data coming off the sensor, or what is the sort of standard deviation of the message frequency off this sensor. And I can also set up quality of service requirements between each of these sort of interoperating processes. All of this is built on an abstraction layer. Generally, this communication abstraction layer is something called DDS. I'm not going to get into a ton of that, but the whole notion of this abstraction layer lets you pick the one that'll allow you to use, or pick the one that'll best suit your application. So if you're going to be communicating over 5G or just general telecom lines, you can use one thing. If you're just doing everything sort of in a real-time control system on one piece of hardware, you can use a different implementation. But essentially, this allowed us to improve security, improve robustness, and give more control back to the sort of developers to build the applications that they want. What's really cool about this is now that you have all these tools to move messages, you have standard messages, you also end up with standard tooling to visualize all these different kinds of messages. ROS has a tool called RViz, which allows you to go and sort of tap into any topic that's running on your robot and see what's going on, which is incredibly helpful for debugging, for understanding what processes are, for building new things, and just sharing information between development groups. And all of this kind of comes in the box with ROS. You can sort of configure whatever GUI you need to go and do what you need to do. Probably should check here. Questions? Oh, quick question. Is there a migration path from ROS to ROS 2? And does that also fall under the in addition to? So there is a rough migration path, which is to say I would personally recommend jumping up to Noetic, which is the last ROS 2 release that is a Python 3, ships with Python 3. Jump up to Noetic. That's a nice unit step of work. And then once you're at Noetic, jumping up to ROS 2 is just sort of another release, more or less. I mean, there's some tooling. There's also the ROS 1 to ROS 2 bridge, which you can use if you're migrating a very large system. So you can move things over piecemeal, but that's generally the process I recommend.
Cool, thanks.
Cool. All right, so what else is going in ROS? So ROS has another wheel you shouldn't reinvent, which is bags. So a bag is just a standard serialization. Let me make this full screen. A bag is just a general ROS serialization library for serialization data out to disk. We call basically a big collection of data that's sent out to disk a bag, and a bag is wonderful. Is a wonderful tool for sort of, hey, it's basically a VCR for your running robot. So you can say, hey, my robot's doing something, press record, drop it all in a bag, ship it off to your coworker somewhere on another continent, save it for later and go and debug it. Or you can record sections of your behavior and add it to a machine learning data set. There's a lot of different options, but this tooling alone is phenomenal and is extremely helpful for just debugging and sharing information about a robot. You can even take these bags, record them, and then replay them in your unit tests to give you like real world unit tests or real world data based unit tests to sort of fix things as they come up. Like I said, these things are absolutely amazing. They can go out your unit tests. You can use them as like a black box for recording a robot, or for recording sort of behaviors for a robot that are degenerate. You can send them off to collaborators. You can use all that data for machine learning, computer vision, deep learning training. It's all sort of, hey, once you can serialize something out to disk and send it, you can use it for a bunch of different applications. You don't have to take my word for it. This came out maybe 3-4 months ago. Basically, Ford has been driving their autonomous vehicle contenders around Detroit for a while, through the snow, through the sun, and has put together a giant database or a giant data set of essentially LiDAR and camera data from vehicles driving around they can go collect. And it's all ROS bag based. Other researchers like over at ETH Zurich have been using ROS bags as like their data distribution collection framework. This is a very standardized thing at this place. It just works because you're just basically hitting record and dropping everything into a file and sharing it. The next sort of primitive that I want to talk about in ROS is the notion of an action and a service. So if you've been, if you do anything hardware related or even responding to users in any sort of way, you're familiar with sort of either building synchronous behaviors or asynchronous behaviors. So a synchronous behavior, right, is something that you do where the user responds immediately and there's no delay in something happening, right? So you have a response almost immediately. An asynchronous behavior is something where, hey, you go do something and then you're just going to wait indefinitely for something to come back or something to respond, and then you're going to have to take over control again. And so writing asynchronous behaviors can be really, really hard. So writing GUIs are really, really hard. And what happens with ROS is that there's basically built-in primitives for building both synchronous and asynchronous behaviors. And we call synchronous behaviors services and asynchronous behaviors actions. Within ROS, actions or asynchronous behaviors handle request negotiation, handle preemption, and work with callbacks. And all of these APIs are basically callback-driven APIs, which makes it very, very easy to like abstract away all of this sort of mechanisms that you need to do this and just fill out the behaviors that you want. The way I sort of, to give an example, right, in our very, very simple robot, if you want to send a command that says, hey, pick up a red ball or something like that, right? First, you got to say, hey, am I able to do that? Are my hands free? Can I see your red ball? And then you can respond, yes, I'm going to go do that. And then you can say, find the ball, move hand to position, blah, 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 pick the thing up, and then return, hey, I've done that. So building that within ROS can be done fairly quickly because it's all an action, right? And so each of those steps in the process can be defined as a simple callback. And since those are all API driven, it's fairly quick and easy. You're just sort of going from a formula. This is how I build ROS actions. Similarly, ROS has a ton of tools for geometry and kinematics. So if you're not familiar with like kinematics, it's solving the problem of where is something that is attached to my robot, or where am I with respect to something else? Or how do I get from A to B? Or I can see X, am I able to grasp it? And those sorts of problems are all fairly simple to solve with ROS using something called TF. So in ROS, there are two concepts you need to know about. The first is a Universal Robot Description Format, or URDIF, which is a great, it sounds Swedish name. We call it an URDIF, so it sounds like a Swedish name. And it basically defines the 3D geometry of your robot, and it can be exported from your CAD system. And it allows you to say, oh, I know this linkage in my robot is this big and has this sort of mass distribution, and that to go from this finger to this elbow to figure out what this translation is going to be this link plus this link plus this link. TF2 or Transform 2 is the ROS library that basically automates all of this for you. So you don't really have to think about doing all these calculations. You just can say, hey, I want this position in the frame rate of, the head or with respect to this position on the head of the robot. And all of this is, I see people try to rewrite this. You shouldn't rewrite this. It's difficult stuff, and it's all baked into ROS and solves all these problems automatically for you. Along with that, you have the issue of forward and inverse kinematics, which is to say, I know positioning, but I want to move something in a robotic system, right? I need to figure out all the joint angles that take something from over here to over here. And I need to do it without hitting anything or colliding on, hitting myself or hurting anyone else. And so within ROS, there's an entire external package called Move It that actually will do all these calculations for you and lets you sort of set up what solvers you want, what constraints you want to do that, and gives you a nice sort of friendly, GUI user interface to build some of these primitives. Another thing people often want to do with robots that is sort of baked into ROS is doing navigation work. So you have, and if you have, say, an AMR or something that's similar to a Roomba that's moving around a house and it needs to plan its way through that house, ROS basically has a couple of different versions of a SLAM stack that you can drop in to your robot and hook everything up, and you do a little bit of configuration, and you should be able to use your sensor data just to move your robot all around the world. Recommend the ROS2 nav stack. If you want to do that, you can check out the, I think it's nav.ros2 or nav.ros.org or navigation.ros.org. All the documentation there for nav2 is ready to go, and you can kind of learn about it. Another tool that we provide or is provided through ROS is simulation. Generally speaking, robots are expensive, they're dangerous, they're slow, they're hard to share, you can't take them home during COVID. If you're writing tests that run on a robot, they're going to take forever. And fairly quickly, people figured out, hey, maybe it's not always best to do my software development on the robot itself. Maybe I want to have a virtual machine robot that I can go and run all my tests on, and when I think everything runs correctly, I can actually go put it on the real robot. So ROS actually has simulation tools all ready to go. As I was saying earlier, you're able to basically build a simulated robot, build a simulated world with physics and simulated sensors, and actually test out how things are doing, or how your algorithms work, whether they perform correctly, and you can do it all without leaving your desk. The simulation framework we have is called Gazebo, or Ignition Gazebo is the newest iteration, and a ton of people are using it. This image over here on the right is from a project called ARIAC from NISC, where they simulate this entire large factory of the future, and people are able to go and grab these simulated robots and show how they'd use them and how they would put together this factory to automate it better than the last person. Down here in the center, I just have an example of, here's that nav stack that I was just showing you, and then it's actually being deployed inside of a simulated house. And you can see that hey, here's a simulated sensor, here's the sort of simulated processing that comes out of the sensor. ROS packages. So I've already kind of touched on a couple packages, but ROS has this concept of packages. They're kind of like a collection of code that can be recombined. If you're familiar with Python packages, same thing. ROS packages can be built out of C++, Python, or just about any language. And ROS Federation basically means that you can go drop this package into your project and have that functionality fairly quickly. A good analogy is something like pip in Python or Python wheels. It's this exact same thing. So, if you need to, and what's cool about this is if there's something you want to do, like say, hey, I want to put my robot's display up on the web, There's a set of JavaScript tools for that sort of visualization. We also maintain ROS index, which is kind of like your PyPy that you can go and search through and see if there is a ROS package that works well for you. Another great thing about ROS is that we just sort of have plug and play hardware, and it follows straight from having this notion of packages, right? So somebody makes a package for a piece of hardware. Now all of a sudden you don't have to write that hardware interface to that, or write the interface to that hardware. You can just use the package and it just works. So I have a couple different examples of ROS hardware, or hardware that supports ROS and has a ROS package that should work out of the box. So there's Universal Robot ARM drivers. This is the Ouster OS1 LiDAR. SICK laser scanner should work perfectly well. Intel RealSense depth camera. All of these things, just a ROS package. You should be able to grab a piece of hardware and get it running within ROS within 15 minutes. This is something that's new in ROS 2 that's growing very, very quickly. It is micro ROS. So early iterations of ROS, we were very focused on building sort of high-level tools for robot development, and sort of neglected to a certain extent the low-level control architecture, or the ability to run things on low-level microprocessors. That's all evolving rapidly. And so within the past year or two, this project has started taking off, where you can basically build a baked-in ROS interface to all sorts of different kinds of microcontrollers. So if you're interested in, like, say, ESP32s, or like some of the STM line of processors, you can deploy basically a little bit of code that creates a ROS interface to these hardware components. And I think this is going to be a really, really interesting and powerful feature in the next few years. Stop here, and I'll show you guys a couple community resources. Any thoughts on RISC-V? I'm for it. I mean, I don't think there's anything that's going to be there just yet, but I'm super excited. I don't know who's calling. Okay, well.
Probably. Yeah.
Okay, well, I'm going to go through and I'll just show you guys a couple of community resources we have out there right now. So generally the main entry port we recommend for everyone is ros.org. That should get you sort of directed to wherever you need to go in community. There's also index.ros.org. So this is, or /doc/ros2. This is right now where we're keeping all of the canonical ROS2 documentation. It's not in the ROS wiki, like where we kept all the ROS1 documentation. So it's a little bit harder to find right now. We're actually doing a fairly substantial overhaul to all of this to get it laid out for the long term. But if you want to get started and start to understand like the basics of ROS2 development, this is a really good place to look. We also have our own discussion forum. So this is ROS Discourse, and there's where you're going to see announcements. I do sort of like a weekly blog post talking about, what's going on in the ROS community, what's new packages. We actually have our own Q&A website that is basically predates Stack Overflow. So if you have a ROS-related question, you can go to answers.ros.org and hopefully you can get it answered, or if you can search through the questions, somebody may have already asked it in the past. So I'd highly recommend, if you have some basic ROS questions as you're getting started, this is a good place to look. Finally, so ROS2 Foxy. ROS2 Foxy Viceroy is the 6th ROS2 release. It's the first major ROS2 LTS release. Basically starting about 6 months ago, there's going to be 3 years of support and patches for it. So it's sort of the one we're recommending people start out with. Yeah, and upgrading should be fairly easy. The H release should be, I think, in 2022, and that should have 5 years of support after it. So really right now is, if you're interested in ROS 2, it's a good time to get started, and it's a good, Foxy would be probably your best choice for getting started. If you're still looking for resources to learn, I can highly recommend some of the tutorials we put together for the Sub-T challenge. So basically there's a whole simulated robot cave environment and multiple different simulated robots, and we have a bunch of blog posts that walk you through how to put your robot together and how to do stuff like automate perception and automate exploration and automate like multi-robot communication. It's all there in C++ in this blog post. Also, I think maybe about 6 months ago, we put together a fairly substantial AutoWare autonomy class. So this class will walk you through how ROS is being used to build a software that's being used to automate or build autonomous vehicles. And we walk you through all the different topic areas from ROS basics to different kinds of LiDAR and how to use them and how to automate camera systems and how to do control. And it's a fairly substantive AutoWare course. And then finally, as I said previously, there's the ROS 2 docs that we recommend people go and take a look at. And finally, if you want an actual robot to take home and play with you, our sort of recommended platform, the one that we sort of endorse, is the TurtleBot. So you can pick these up from Robotis, and they're little tiny, well, one's little tiny, one's a little bit bigger, dinner plate size robots that all run ROS, and we use them as sort of our core teaching platform for ROS. Cool. So that's what I got. Hopefully there's questions. I hope that was at the right level. I wanted to give like a quick overview and what's in ROS without being too much into the software weeds.
Thank you.
There is a ROS Discord server. That is not an official ROS Discord server, though. I will say that. But yeah, feel free to go chat.
Thank you, Kat. So, Herman, you have a question? Actually, before I go to Herman, I was curious about Colin's question. Colin, what were you thinking in terms of RISC-V and robotics? Do you have an application? Is Colin still on?
I don't have anything specific in mind. I was just interested to hear if ROS has any future plans to get involved with it.
Cool. All right. Herman.
I mean, I think.
Hello, can you guys hear me? Or, oh, was I supposed to? Hi. Hi, Catherine. Thank you for the presentation. That was really cool. I was wondering, since robotics platforms, it's by default like hardware related, and most tutorials you do online is just like software. So, is there any particular tutorial or introductory thing, like maybe you even have to purchase some hardware that will help you introduce to like the whole node sort of 3-piece thing? Like, how do you get something going with ROS that's actually a physical device?
So the short of it is, all those resources that I posted at the end, I would go through them in reverse order almost. So the ROS 2 docs will show you something called TurtleSim, and it'll just show you the very, very basics without any robot attached. It's just, here's how to write the software. At least for the AutoWare stuff, I have like 3 hours of lecture walking you through every inch of that, software, like walking you through building your first node, building the topics that go through it, building actions and services, and how to run them in the command line. So that's both in the ROS 2 docs and in that AutoWare, the first couple lectures in that AutoWare series. Once you feel comfortable with that, I'd grab some of the DARPA stuff, because there's just a Docker container. You can fire it up, and there's a environment for the robot to run around in, and there's a bunch of different sort of hardware attached to it.
Okay, so when you say that there's an environment for the robot to run around in, so this is all in a simulation?
It's all in a simulation. So you can build an infinite world and drop your robot right into it and say go, and it will do what you tell it to. And we walk you through sort of the steps to make that happen.
Right on. Very cool. Thank you.
Mm-hmm.
So I actually have a related question. So in terms of hardware support, I assume that there's a list somewhere of what's supported. Is that the packages?
So there's no, I won't say that there's any sort of formal list. Okay. I think it's sort of, personally, I think it's on the vendors to do that, but most vendors don't do that.
Yeah.
I think your best bet is Google ROS package plus hardware name, and something usually will come up depending on what it is. I think certain vendors do a better job than other vendors, or have a bigger community supporting them.
Okay, cool. Slides. Okay, yeah. So I have a link to the slides. I'll share them in the Meetup group and also on the robotics channel on Discord. So I'll share them out. Stuart. You have
Hey,
a couple of questions, or you had a couple of questions.
well, I had a couple of comments, and I did have one question. Kat, it's good to have you presenting here. And I got to say, I've been using ROS for about the last year, and ROS has a ton of great functionality in it. Anybody doing robotics would be a fool not to use it.
Awesome.
That being said, a common thing I hear is that ROS has a difficult learning curve. I mean, I experienced that myself. Like, you get documentation that's kind of out of date, or you have people use different terminology, or they use different generations of tools. And as a beginner, you go into that and you end up like cutting your fingers a lot as you learn this. I'm kind of wondering what the thoughts are in the community around this. Of like, I know that there are tutorials and there's like videos and stuff like that, and those are all helpful. But at the same time, I keep on hearing this, and I kind of wonder what the thoughts are about like how we can make this easier for new people to come in and get up to speed.
Yeah, I mean, part of it, I have a lot of thoughts on this, right? And part of it is just a matter of also having the resource. Like, I think fundamentally us having resources to build the definitive guide would be nice, and we just don't have that. So what you have is a piecemeal of things, where I think there are quite a few fairly newer things that are pretty good. I mean, at the same time, I think my entire career, people have said, well, if we could just get this really hard thing to be dropping 3 things together and connecting them, right? Well, the reality is that sometimes just learning hard things is hard, and I can't always make that easier, or you're going to do a trade-off between, conceptually easier to understand, but maybe not functionally correct. So I'd like to believe that there are things out there that help. There are a ton of tutorials, but I don't know if there's one glib answer I can say where, oh, it's going to be easier, right?
Yeah.
Yeah, that's fair. I mean, it's a hard problem, and clearly there are people trying to work on it. So, I apologize for putting you on the spot and saying, it's a hard learning curve, but at the same time, I know that this is something that you and other people have spent a lot of time thinking about, and that's why I was wondering, like, what the direction was.
Yeah, I think so. The other thing is I haven't gotten to take a look at it, but I know what the general content is and how it's laid out. I know Amazon just put out a huge set of tutorials, and they do it in a way that is, fundamentally what I'd like. There are also vendors doing this, like the Construct does a really good job of this. I, at some point, would love to be in a position and have the resources to go and write something along the lines of, here is your simulator, here is everything through, step 1 to, from soup to nuts, doing everything that you need to do. But the reality is I don't think everything's there yet, and we just don't have that. If you look at the Robotics documentation for the Turtlebot, I also think it's fairly comprehensive. Now, whether it's easy to understand some of these concepts, I don't know, because they are, I also think, like, this is another kind of one of those philosophical questions. I do think people, believe, oh, well, I could get into web dev so easily, right? That, like, I just open up my web browser and I type a few things, and all of a sudden something pops up on my screen. How do I get it to be that easy? And I don't know if there's always an answer to say it's going to be that easy.
That's a fair point. I mean, it's a deep area, and I think we have to have a little bit of respect for, like, there's a lot more material and knowledge there than people realize sometimes going into it.
Yeah, 13 years of knowledge.
Yeah.
Yeah. That's a good point. Maybe it's a community task to get it sorted out. Cool. Thanks, Kurt.
Yes, it is bottomless.
Misha, do you want to ask your question?
Yeah, sure. So I heard that, again, read in a couple places that Linux might be better for using ROS 2, even though there's a Windows implementation already. I guess, like, you'd be the person to know. Is Windows just as effective, or is there, like, a reason to use Linux still?
There's always a reason to use Linux. So this stuff is fairly nascent. I mean, I'll be quite upfront. Like, the Windows community is doing a lot to support it. We want to help make sure that happens, but at the end of the day, all of the core devs and almost all the ROS users I know are using Linux, so that I think would indicate what's going on. I mean, if you think about it, a lot of the, and a lot of that has only been made possible in the past few years because of things Microsoft has done, correct? And so, do you want to use the thing that's the original free operating system, or do you want to use the thing that's kind of bolted on top of Windows? And it may be really easy for you to do as your desktop. I think that will make life easier. If Windows is your core desktop and you want to learn that way, I think that's great. But very rarely do you see people running a large robot or even a small robot with Windows on it, right? They're almost all Raspberry Pis or Nooks or some smaller computer that's running Linux underneath it. So, to get started, you're probably okay, but you don't see it as much, so there's going to be a lot of rough edges that need to get filed down.
Okay, thank you.
Yeah, there's probably lots more support too if you get stuck.
That's a good
At
point.
this stage. Cool, good question. I was wondering that. David, thank you for the link. Eric,
Yeah.
want to ask you a question?
Yes. Hi, Catherine. Thank you for your presentation. My question is about, does ROS have instrumentation for determining when the load that you're putting on the system is starting to exceed the capacity of your hardware? So, for example, if you see message latency starting to increase or things like that, is there any built-in or modules for that?
The short answer is yes, right? So the way I've seen this done, the way I do this usually, there are some new topic tools that allow you to say like, okay, so all ROS topics, you can go in, there's a command line thing, it'll say like how much data is flowing through this, what's the rate, what is the like standard deviation on message frequency, all of these things. So it's a mixture of that plus sort of your standard issue Linux tools, right? Because I know as the developer, if I go to a machine and it's acting wonky, first I run htop and see like what's going on, and then like once I kind of have a rough idea what the process is it ROS related? Yes, okay, use the next set of ROS tools to say like, okay, what topics are running, how much data are going through these topics, how are things performing? But there are a ton of tools for diagnosing these things. It's kind of endless too.
Another bottomless.
Yeah, I mean it's kind of like, well, what is your mode of failure? So you could go use something like Plot Juggler and plot everything as it's coming along, if that's where the error is. If it's more of like, for any system problem, right? You're figuring out, is this basically something where I'm hitting memory swap? Am I exceeding the capability of my CPU, or am I like doing too much file IO and my disks are about to explode? Like, it's sort of that whole process of debugging requires a whole bunch of tooling. So it all exists. It's just like what tool you choose depends on like sort of the tree of which thing I'm going to do.
So there's lots of tools. Cool.
There are lots of tools.
Okay. Robert, you have a question about micro-ROS.
Yeah, so there used to be another process for communicating back and forth between a main ROS processor and microcontrollers, and I've forgotten the name, but I've used it many, many times. So is micro-ROS now going to be that thing?
So there's multiple things. Probably ROS serial is what you're talking about.
Yes, correct.
It's not, again, it's one of these, it's non-exclusive. I don't think there is going to be the one way, right? When you have a community this big, there's never going to be the one true way. It's sort of like, this is an option for how you do this. I think it's a better solution because you're actually, you're interfacing things on the microcontroller level, so you're not having to deal, like you can do error correction, you can do sorry, there's feedback there. That. But yeah, there's a lot of different options. I think in the long term it's the better solution just because it's actually running on the microprocessor versus you rolling your own sort of software on the microprocessor and then having it talk serial up the chain. And I think that's at the end of the day going to give a better user experience, especially when we start talking about things that are sort of packaged as ready to go. Because I would like to get to a world where you can buy something and it's sort of plug and play. And I don't think we're quite there yet.
Cool. Okay, next questions. Colin, I like your comment. Oh, baby, it's bottomless. Yeah, there's lots of choices. David, you ask your question on sub-T, and thanks for sharing the links.
On a Raspberry Pi, I don't. You can run a lot of introductory ROS things, but once you run a simulator is just a video game. So be mindful that you're going to want a graphics card.
Yeah,
I mean,
that's exactly what I was looking at in the subterranean, in the sub-T project you shared. I went and took a quick look, and it's calling for NVIDIA CUDA. So I assume that's desktop class as opposed to like Jetson Nano. But I think it was really more of just a general statement of like how, once you start getting into, like you say, the simulation, I mean, you're talking about like pretty serious gaming PC territory then, or not really?
Yeah, I mean, it's a simulation, right? It's a video game. We say simulation because we don't want to say video game, but it's a video game plus like all the physics and all the sensors and all the other things. So it's usually running things in simulation requires some horsepower, but at the same time, like there are, at least within the ROS2 documentations, these like, I just want to learn the bare bones, like basics of ROS, the ROS, like Turtle Sim, that will all run on a Raspberry Pi, but the big hunking simulation where we're going to go down an 0-mile-long cave, that's not going to run.
Cool.
Makes sense.
Matt had a comment. Matt, do you want to add anything else around this topic? It sounds like you run it quite a bit.
All I want to sort of add is that, I agree with what Katherine just said. ROS can run on a Raspberry Pi. We often do that, and we have customers who are running robots using Raspberry Pis. A typical sort of setup is that we'll do our simulation on a desktop and have some of the nodes running on the Raspberry Pi and the rest of the nodes running on the actual desktop, and they're linked over the network. And so that's one thing to be aware of, as you're working with ROS and you want to build, say, a robot that you can drive around your house. You can do that with a Raspberry Pi and get started. But you'll probably be also using your desktop as well, communicating with the Raspberry Pi as it does so. You'll be doing the simulation, the running RBiz and RQT on the desktop, while you're driving your motors and maybe some sensors on the Raspberry Pi. And as long as you're not wanting to do say object detection or any sort of computer visualization, vision processing on the Raspberry Pi, you should be fine to get going and get off the ground. And with the Raspberry Pi 4, it will take a while to outgrow it.
Yeah, they're pretty beefy. It's the simulation aspect that you don't want to run on there. In terms of robots, like all the turtle bots can run on a Raspberry Pi 3. It's not. The real issue is just doing the simulation. Like that kind of stuff is all, and some of the visualization. That's all better off on a desktop, or a beefier laptop should be fine. Really depends. I mean, it's like all of these questions are. It depends. So.
Okay, thank you. Thanks, Matt. Frederick, welcome. You have a question.
Yeah, absolutely. Was just curious about micro-ROS once again, and you mentioned that you work with RTOSs in that department. So which ones are supported right now?
Well, I don't work with them, so take everything I say with a grain of salt.
Okay.
I believe right now it's Nutux and FreeRTOS, but I would go look at their website because it should be listed right there.
Yeah, sure.
DuckDuckGo, micro-ROS, and first hit should be fine.
Absolutely. I will have a look. Thank you.
Mm-hmm.
Thanks, Frederick. Herman, you have another question. Go for it.
Yeah, I guess this is kind of like a follow-up to my previous question. And since we were talking about Raspberry Pis, I was just wondering if there's like an official hardware kit that like you guys recommend to use for just starting out development if you wanted to move into like a real physical robot. So is that Raspberry Pi, or is there something?
Our official robot is the TurtleBot, so that's the one we suggest and the thing that we've built stuff around. You're gonna have no problem on a Raspberry Pi. Like there's a bunch of different ones out there. There are a bunch of different people building their own that'll run you through stuff too, or selling kits to do so. So there's no, we don't have a ton of official anything, but there's better choices obviously, and the official line is the TurtleBot.
Okay, cool. Thank you.
Cool. That was the last question in chat. Anyone else on any feedback, comments, questions? This was awesome.
Yeah, the only thing I would like to say, it was a great presentation, and the TurtleBot is awesome. We've got one at the foundation, and I have an intern working with it right now.
Which robot?
The TurtleBot. We have a TurtleBot burger. I have an intern working for me, and is exploring specifically, working with AD-Link essentially on Cyclone DDS and then Zeno over the TurtleBot using ROS2 and all of that. So it's a nice mix, and he's been able, he's a computer science student, but no industry experience, and he was able to pick up the stuff in a matter of weeks with the help of the AD-Link guys. But still, it's fairly complete as a package, and the barrier to entry seems low to me, so it's great.
Yeah, I mean, it's not easy. It's not as satisfying. I mean, I think I also teach kids like how to do web development. It's not as quick and as satisfying as like, hey, I change a few lines and the thing turns purple. But it's also the dopamine rush of, oh my god, I spent a couple hours setting this up, and all of a sudden now I have a robot that moves around. The dopamine rush hits a lot harder. So it takes a little bit longer, but it's totally worth it.
Cool. So Frederick is with the Eclipse Foundation, and we just had him talk about what they're doing with open source and IoT. So Frederick, what's Eclipse's interest in ROS and robots? Are you guys working on that as well?
Yeah, well, absolutely. And in fact, Open Robotics is one of our members, and we are working closely with Open Robotics, AutoWare, both on the industrial automation aspect, and then there's the whole automotive aspect where we have distinct working groups. And I think I should get in touch with you, Katherine, and invite you to our Eclipse IoT working group meeting so that we can spread out the ROS community.
I will go to any working group meeting. I go to a few a week, so let me know. I can drop by.
Yeah, cool. Absolutely. I will get in touch. But yeah, our interest is really driven by what our members are looking at. And right now, AD-Link is one big driver on both on the ROS2 side of things and in our own ecosystem of IoT components. And then on the autonomous driving side, AutoWare is a big part of what we believe in as well. We also joined AutoWare since we support the initiative, and we are in discussions with various people there, especially Apex.ai, which is really influential in the AutoWare sector. So.
I'm gonna interrupt just so people understand. So AutoWare, I guess I probably didn't explain this as well as I should have. AutoWare is effectively a group, for lack of a better word, it's a group on top of ROS. So like ROS is like the low level, like make things run. AutoWare is a group on top of that just says, let's build higher level tools just for vehicle autonomy. That's what AutoWare does. And so that's sort of the relationship there. That's why I'm pointing people there.
Cool.
Yeah,
Awesome.
And in our case, we have 5 automotive working groups looking at various aspects of that specific ecosystem. But one of them, called OpenADX, is really focused on validation tools for AI that you would put in a car. So if you need to validate something, then that something can be AutoWare based or something else based, and that's why we are working closely there.
Oh, awesome. All right. Well, I'm going to reach out to you because this sounds like another interesting follow-up meetup. To see what's going on higher up in the stack.
Or somebody else, but
I have a follow-up to that one actually. Is there an industrial equivalent to AutoWare?
Oh, good question.
There is an industrial equivalent. It's ROS Industrial. It's also called Rosen or Rosen in Europe, And then there's also ROS Industrial Asia Pacific. So there's actually a different industrial consortium on 3 different continents. But ROS Industrial, the one here stateside, it's at Southwest Research Institute down in Texas.
Okay.
They actually, for what it's worth, their public conference is December 8th. I just posted something on Twitter like an hour ago.
Oh, great.
That's worth checking out. I think I heard a rumor that they have a really good partner they've been working with in aerospace I got to see it. I don't know if I can talk about it, but basically the biggest robot I know of in America is down there running ROS and doing some crazy stuff, but I don't know if I can talk about it. So it's
okay.
It's really cool. Also, for that matter, biggest robot I can talk about running ROS is that there's a giant fake Gundam in Yokohama Harbor that's supposedly going to run ROS. If you Google life-size Gundam Yokohama, this guy's building it. It's going to run ROS. Actually, there's a gazebo model for it too, so I think you can go drive it around.
Oh, very cool.
Actually, you just mentioned gazebo. I had a question about gazebo. So is there simulation data that's already available? So you had the Ford website there. Like, are they sharing their data?
Well, so that was actually captured real world data for validation machine learning. Simulation wise, there's Ignition Fuel, so there's basically a website where you can just drag and drop 3D models into your simulation. Also, a couple of different groups have released various simulation environments, like Amazon just released a couple of them. I think the DARPA stuff, there's all these crazy, weird little cave blobs that you can hook up together to build your own arbitrary cave to go test your robot on. So there are different simulation worlds that you can put together.
Cool. Awesome. All right. Any other questions? All right, cool. Thank you very much. Thank you, Kat. This was awesome. And I assume the slides are, I can share the slides out, and I will share those out I'll post them in the Meetup group, and also, like I said, on the Discord channel. And thanks, Kat. If you think of any other cool presenters, especially people showing off real-world ROS applications, that'd be awesome.
All right, let me go talk to a few people in Seattle. I think we can do that.
Awesome. Cool. Thank you. Thank you, guys. Okay.